Hello, in this video today we're going to explain the overcurrent application within TDMs package of software made by ISA. This video will mostly focus on explaining what is the functionality of this software, and some examples will be shown later. In order to do that, we click here in overcurrent and we choose, in this case, earth fault overcurrent 50, 50N, 50N, 51N, 67N. Now opening this shows us a nice screen, and we'll go step by step to explain what is what. Of course, using TDMs, you can, when you execute a test, save a file which can afterwards be run on other relays which have same or similar characteristics. So for that reason, we have here the option open, with which we would be able to open a certain file which we saved before, or if we want to create a new file, we'll press new here, and now we have, let's say, a new file for testing a new relay. Save happens when you press this. Save in TDMs is an option to save our results in local database. Print, self-explanatory. Then we come to header. Header is an important thing if you want to create a quality report. So you would punch in the plant name, feeder, voltage level, or some other name of the feeder. Relay manufacturer, in this case we chose the Siemens 7SJ relay, location, operator, and instrument serial number, which is usually detected directly right away after you connect to a DRTS. We are not connected to DRTS right now, so I had to write this number down. Then digital inputs type. Here we decide whether we want to have a dry contact, a DC contact, or an AC contact. We can set, as you know, in DRTS we have groups of 2 contacts, so C1 and C2 can be a dry contact, and then we can say that C3 and C4, for example, can be a DC 110 volt contact. I have to press exit because right now I'm not connected, as I said, to DRTS, so I cannot press OK. Now, after digital inputs type, we have advanced settings. These are, as the word says, advanced settings. Here you will be defining if you want to parallel or put in series current outputs. You will be defining what is your V4 output. Also, are you using a transcope? In some other cases, here, are you maybe using low current testing, low power testing? And in the end, last tab, you can also make icons slightly bigger or slightly smaller than they already are. Moving on, these 2 buttons define whether we are perceiving measurement of time in seconds, which is this one, or in hertz, as here, meaning in cycles. So since I defined my cycle as 50 hertz, 200 milliseconds is 10 cycles. Also, since I defined my relay having a 100:1 CT ratio, if I say 1 amp secondary, this would be a 100 amp primary. Or if I want to see these values not in absolute but in relative, since I have nominal current of 1 amp, I will always have the same value as before, but as I press relative, I see that this now becomes 1 I over IN, whether when here, if I press, this is 1 amp. This button here would connect the TDMs to the RTS. By pressing this, we would choose which test set we want to connect to, which connection, USB or Ethernet. If Ethernet, what is the IP address, and if for some older relays we can also use RS-232. But right now we are not connecting. And this button here allows us, once we connect to the RTS, to generate only DC output. That means we have a special DC output on the RTS which is used to supply the relay or transducer or whatever. What will be the output? You can find out here. You see when you press this button here, relay settings, the DC supply is 110 volts. Also, we would generate the pre-fault values by pressing this button, and if we want to start an actual test, then we would press this button here. Of course, they're all grayed out since we're not connected. The button stop does stop the testing, but it returns the state to the pre-fault state. If we said that the pre-fault is a certain generation, let's say 0.5 amps, then by pressing pressing stop, we will not completely cut out generation. What we would do is we would move back to the pre-fault state. So still the DRTS will be generating the pre-fault values. If the pre-fault values are 0, of course, we would have also 0 on the outputs even if we press this. But if we want to be sure that we have the output 0 on all current and voltage outputs, we should press the reset button. Having said that, I have to add that if in the local control of DRTS you decide that the DC output, the specialized power supply DC output, is always constant, even if you press the reset, that output stays the same, it doesn't go to 0. Next two buttons will be used if you want to test the relay for IC61850-8 goose messages or -9 sampled values. And the next few buttons simply define the view. What are we going to see? Now we see this button here shows us this part of the screen. So if we click it, we will just see the characteristic. And if we now click it again, we will be back. This button here shows us just the overcurrent characteristic, and this button would show us the angle, which we don't see right now. And these two buttons show us both in vertical or horizontal fashion. Now, if the next button, which is very important, is to define relay settings. When we click this, some basic settings are asked. First of all, what is the DC supply? As we mentioned before, what is our nominal frequency? And then we'll skip right away to generation mode. You have 4 generation modes. The most standard one is 3 voltages and 3 currents, and you will use this when your relay is being fed analog signal through standard CTs and standard VTs. By standard, I mean the CTs and VTs you usually have in your substation, and by non-standard, for a CT, I mean core balanced CT, and for a non-standard VT, I think about open delta VT, because a core balanced CT measures only the I0 component, and for that reason I need to have only one input on my protective relay. Also the same is true for open delta VT. So if I have, for example, a relay which is being fed signal from an open delta VT and a core balance CT, I will say 1 voltage, 1 current. But if I have a standard current and voltage transformers, I will have 3 voltages and 3 currents. You see that if I say 3 voltages and 3 currents, I'm just having this part of the screen, so I have to say what is my VT ratio and what is my CT ratio. But if I have 1 voltage, 1 current, meaning if I'm using open delta and core balanced, then these values here are valid. The program doesn't even look at these values here. So, and here I would write what is my core balance CT ratio. Start point side, of course, very important for directional, towards busbar or towards the line, or as towards the protected object. In this case, line is the protected object. Polarizing quantities are the values used in our directional protection to discriminate in which direction the energy is moving. Usually they're VRES and IRES. In some rare cases they can be 3 times inverse component. Angle reference, whether the angle is current or voltage. And positive angle convention is clockwise or counterclockwise, depends on the type of relay you're testing. Residual current and residual voltage are usually defined as IRES and VRES, but in some rare cases they can have different definitions within your relay. Now, having explained this, I would just like to do a short example. I would set a characteristic here, which would start. So the first characteristic would not be a definite time, it would be ISC class A, normal inverse, that starts, let's say, from 1 amp. I will go back to absolute values and seconds. And let's say that I'm happy with this. And also, let's say that my first characteristic is non-directional characteristic. I add the second characteristic with the button Add Characteristic Curve. There is also the button next to it, Insert Characteristic Curve. The difference is, if I press Add Characteristic Curve, observe here, the new curve will be added below the already existing curve. And if I press Insert Characteristic Curve, the new curve will be added above the new curve, the previously existing curve. If I want to delete, I will just press this button. And yes, I'm sure. So now I want to define definite time characteristic, which in my case here starts from 5 amps and trips in 300 milliseconds. Now you can see my curve here. I still need to define my direction, because for definite time my direction is forward, and I also need to say what is my MTA, maximum torque angle. So let's say that the maximum torque angle is 30 degrees, and you see this changed 30 plus or minus 60. And also I would need to change one thing here to say that voltage test value in my case is, let's say, 10 volts. So right now I get my sector. I will explain this now. So we said 30, which is this, plus or minus 60. So we go in a plus and minus direction 60 degrees. So this dark blue is the sector for the second characteristic. The sector for the first characteristic doesn't exist, meaning it's the whole, because I'm not in this part of the characteristic, I don't have a directional protection. So we can now again just observe the sector, or we can just observe the characteristic, or we can check both of them in two fashions. So now when I want to test, I will go here in test settings, and first I need to decide, do I want to generate a certain pre-fault? Let's say I do, for 200 milliseconds. Also, I need to decide what is the maximum test time, but actually this is decided automatically. So if I want to test right now, I can choose click and test. With click and test, as you click, the DRTS automatically generates that value, relay trips, hopefully, and returns the result. We can see what was the testing current here. And sequence, in difference to click and test, is actually the sequence of click and tests. So the sequence means I will mark few currents here. You see that at the same time as I'm marking here, they're also shown here. So as I'm marking them, when I finish, I need to press start in order for all these added points to be executed. The difference is that with click and test, once I clicked, the test was done automatically, and with sequence, I press few points, I mark few points, press start, and then all these points are executed. 3 automatic tests, which are very important, are the test of current. So in the test of current, let's say that we want to check the whole characteristic. We don't want to press 20 times. So we say, I will start from 1 amp. I'll finish at 15 amps with a step of 0.4 amps. If I want to add all these points, I will press this button here, Add Test to Test List. Having done that, I see that here all this is going to be tested. Also here, this is the same thing but shown in another way. And also if I go to the tab test, I will see all the points I made before and also the points I did just now, starting from 1 and going by 0.4, increasing. We can see also as I go down how this moves on the right side of the screen. Moving back, when we do this, we will find out what is the threshold for our current. Analog to that, if we are testing the sector, which is angle, we need to define what will be the testing current, which needs to be above the 1 amp, in this case, threshold, so let's say 6 amps, and also testing voltage, which needs to be above 10, let's say 12 volts, because 10 is the threshold. Which characteristic are we testing? Not number 1, because characteristic number 1 is a thermal characteristic ISE class A, which is non-directional. So with this I can test only characteristic number 2. And again, I can add a test here and see this added test right here. The last 2 tests, this one and this one. We can see the actual test here. They will be done, one test inside the sector, one outside, on this side of the characteristic, and also here. By the way, a very important thing is zooming. So here, if we zoom in, we will surely see better what are we testing. So this is the test of the sector, and this was the test of the current. The third test will be a voltage test. It's a little bit simpler. You will just add this, and the test will be done automatically, because the DRTS will be generating currents higher than the threshold currents within the sector, with the voltage lower than the tripping voltage and with the voltage higher than the tripping voltage, expecting of course first to see the timeout and after that to see a tripping in 300 milliseconds. Last test here is the verification of the dropout ratio. We all know that the dropout is actually, it exists because we don't want sudden resets of a pickup. So with this, you can test the dropout ratio of current or voltage. So these were the basic features of directional overcurrent protection. Thank you for watching.